Okay, and this is our final process that we talk about. It's called tempering of steel. So when we make our martensite crystals or martensite steel, and we said it's very, very brittle, these needle-like crystals are highly stressed in a BCC crystal structure, and they're a bit of a problem because, like I said, the steel is still very brittle. So in the videos that I've asked you to watch, they actually snap a piece of steel with a hammer before they temper it to show you just how brittle it is. So with tempering, what they do is they heat, but to a lower temperature than the transformation temperature. So we're looking at about 200 to 600 degrees Celsius. And what tempering does is it modifies the needle-like martensite crystals by forming specks of carbon inside it. And these flecks of carbon or specks of carbon do what's known as temper the steel. So that's just a very fancy way of saying, we heat it up at between 200 and 600 degrees. These little flecks of carbon appear and then we quench it. And we've got a steel now that is still strong and hard, but it's less brittle. So it's more appropriate for you, say, in a blade situation or other situations where you need a little bit more strength and less brittleness. Now, if you want to see that all happening in a video, you can go to video number 1 at 16 minutes and 40 seconds, and that'll describe that process quite nicely. There was one other process that was discussed, and it was spheroidizing of steel. And that process was a very similar process. It was a heat and cool process, but what they did was they heated it up to a particular temperature and left it at that temperature for a period of time. And what ends up happening is, in your traditional structure of grain structure of steel, a lot of the cementite, which is the iron carbide, is coming out of the pearlite and forming little spheres. That's why it's called spheroidizing. And these spheres basically are surrounded by a sea of more ductile ferrite, and it basically just makes the steel a lot easier to machine. So a mate of mine in the workshop was telling me a story about how he had a student come in and they had a steel ball that they wanted to use in an art installation, and they were trying to drill it and they couldn't drill it. And then what they did was they just heated it up with some oxyacetylene to a certain temperature and left it at that temperature for a number of minutes and let it cool down. And lo and behold, after that it was very drillable. So you can see the magic that happens with these heat treatment processes and the amazing things that you can do via alloying and heat treatment of metals. Anyway, hopefully that's helpful. I'm hoping that these videos and certainly these lectures have been a way of making clearer the things that are actually being mentioned in the textbook. Let me know if this is helpful. Let me know if you have any questions. Thank you, and I'll see you in class.